study.
Daiki Ueno is the GetText maintainer. There's some really cool work in translation and internationalization in general. He's going to be talking to us about input methods and also where his other presenter is. I'm sure he'll talk about as well. So, Daiki.
Thank you. Okay. So, thanks for coming. I think input method is the least favorite topic in at GUADEC because most of the European people don't need input method at all. So, but I try to talk interesting to everyone. And, actually, this talk was a joint talk with Ansh Patil, but he has some problem with visa processing and he's not coming, so I'll try to speak for him about the UI stuff. Okay. Okay. So let's start. Sorry. Wait. Okay. So here is today's topics. Four topics. First, I try to show you the actual use case of the input method, especially for Japanese. And then I'll talk about the algorithm used behind it. And then which is missing and the plan for the future extension. And finally, I'll talk about the whole architecture thing. We might need some change in the future. Okay. So, Japanese input basics. So last year, at the GUADEC, Remat asked me that how did we type Japanese characters when computer was not invented? There was there a typewriter thing? I didn't know at that time, but after the searching on the web, I found this. So maybe some people using it. I don't know how to use it. Okay. So with computers, we type Japanese sentences with 3 steps like this. First we type in ASCII characters, and then it will be translated into the Japanese alphabet. And then if I type space or conversion key, then it will be some actual Japanese sentences. But the interesting thing is this conversion is 1-to-1, but this conversion is can cause multiple results, and there is no single solution. It can be very based on the user's mood or writing style. But if the output is extremely rare combination, then user will think it is a bug. Okay? So I'll show you some demonstration. I can type Japanese character. So if I type, okay. So this is the first step. Then second step is like this, and we can edit afterwards, like okay. And we can assign another characters by candidate list.
Can I ask a question? What keys are you using to change when you do this step?
Basically, we type spacebar several times.
Cycles.
Yeah. Or sometimes type digit keys directly to select the candidate. Yeah. So let's. Okay. So I'll explain some algorithms behind it. How does it work? And it is basically done by 3 steps. First, we split the input strings into several possible substrings and assign Chinese characters if possible, and find the most likely of finite. Okay. So basically, first we try to split the strings into the all possible combinations. It becomes it can be too many, but then it is not finished, and we assign all possible kanji characters to the substrings, and then we put the possible candidates into the graph structure and compute the shortest path, representing the most likely sequences. But say each where in this picture each edges has assigned some transition cost. But the real problem is how to assign the actual cost value. We use data model like something called language model. That is generated from large corpus, and it assigns some probabilities of single word occurrences, or 2 consecutive word occurrences, or 3 consecutive word occurrences. Okay. So the demo I showed that it was generated from Wikipedia corpus. That was from 100,000 sentences from Wikipedia, and also Yahoo Q&A site from 20,000 sentences. And we can also consider some more features of the word to generate the probability, but we only use the notation in this case. And when generating a language model, we need to assure the language model is accurate enough. So in practice, we use some dataset provided by some authorities like Microsoft. That is collection of the newspaper article sentences with correct answer with the pronunciation. So currently it achieves over 90% accuracy. Okay. So the next section, this was by Anish Patel, but for him. So the so basic things are currently working, but what is missing? Okay. The problem is our language is changing over time. And also, when using computers, users' language skills are spoiled over time. So users will expect much more we can provide. So we need to help users in that regard. Okay. So for the language change, most popular language change is it reflects current events. Like, for example, Abe is a Japanese family name, very famous. And it can be written as 4 different characters, 4 different kanji characters, or more. But when Mr. Abe was appointed as Japanese Prime Minister in the last few years, the input method should return the this particular Abe for all political words. Okay? If we show another Abe characters, then users will think this is a bug. Okay? So also language also changes because of some misuses. In this example, sorry, how to explain it, but the first example is actually wrong, but it is popular, more popular than the latter one. So we need to provide both sentences in the input method. Also, we have a lot of communications on the internet forums. So every day, new words or phrases are born. So we need to provide them to the user. Okay. So possible solutions are probably 3 ways. The first one is do conversion in the online services, but it clearly has privacy issues because if conversion online, the server administrator can easily recover the whole sentences. So it's not the way to go, especially particularly for And the second option is language model data. Distribute the language model data more frequently. But the language model data is usually very large, like 30 megabytes or something like. So it requires bandwidth. And the third option is only distribute small updates and merge the language model. But this may affect accuracy, for accuracy, because original language model is very large, but updates should be very small. So if the small data set affects the large data set, then the entire accuracy will be decreased. So we should carefully consider which option should be taken. Also, the next problem is users are lazy, and sometimes while using computers, they are losing language skills, especially writing. So I typed 4 sentences in the demo, but people don't want to type the 4 sentences. Rather want to computer to suggest the next word or something. Also, people can't remember the formal usage of words, so people need some help of the how this word can be connected to other words or something. Okay. And the last one is we have nearly thousands of characters, so we can't remember how to pronounce it. So So sometimes users want to look up the characters by shape or something. Okay. So possible solutions for this problem is predictive input and handwriting input. The predictive input is a kind of some people already use it, but on particular smartphone or something. It is a system that suggests the next word from the large corpus and also the input history. Actually, there is many implementations. PO Box is for Japanese mobile phone, but other input methods are for desktops and actually used. Okay? The issue is the history of the predictive input is very sensitive data. It can recover the whole sentence very easily, more easier than the whole sentence conversion. And the solution to another problem is handwriting input. Handwriting input is finding a character by the handwriting shape rather than pronunciation. So I didn't know, but Mac OS X has the feature from the Snow Leopard. And yeah, iOS also has iOS handwrite, but not very much maintained or used. So the issue is but especially using handwriting input on desktop, the accuracy is a problem because using mouse is not good for writing a character shape. Okay. Also, these two techniques are very good, but if we bring these features into the GNOME, we need new elements like drawing pad or something more suitable candidate based, because in predictive input we should provide not only words but also phrase. So we need to accommodate a shorter sentence, shorter string and either string in limited areas of the input. So we need to think seriously more about the predictive input candidate list. And also some applications already providing suggestions, like web browsers has suggestions list in the search box or something like it. We don't want to interfere with existing application. Also, we actually have implementations in iBus, but they are currently considered as a proof of concept because it is implemented as a separate engine and not backed by the actual intelligent engines like Anakanji conversion mapping engine. So we need to make all the iBus engines can benefit from these new techniques. Okay. So finally, I'll show some architecture proposal. Maybe I'm not sure it is good, but yes. Yeah. This is a little bit what if I propose some architectures, maybe the usual reaction is you are proposing some iBus alternative or iBus competitor. It is known. It is a very bad thing. Remember the flame wars in the mailing list. So actually, I want to improve the IBUS architecture. Okay. Because I'm also IBUS developer, so it is ideal if we can improve the IBUS architecture itself to be suitable to the new input technologies. So let's look at the basic architecture of the IBUS. Traditionally, input method architecture was looking like this, something like SCIM. Okay. So it is really a monolithic system. So it accommodates several engines in a single process. And for providing input method features with GTK, then communicate with this system through the GTK-IM module. But this architecture has a potential pitfall because potential drawback because some of the engine has crashed, then the entire system will be unusable. So then to solve the issue, IBUS was designed as a multi-process architecture. So in this architecture, if a PE engine or Kanakanji engine crashed, the system itself will continue working. Okay. This. So there are three components, but look at later. Okay. The good thing of the IBUS architecture is now the architecture is crash resistant. But the drawback is performance, because for processing one single key event, we need to relay some key event to the GTK module IBUS daemon and the engine, and then send back to the result. This causes some latency or something. Okay. So actually IBUS consists of three components. One is the IBUS daemon, and second is engine, and the third is panel. IBUS daemon is actually a re-implementation of DBUS daemon. It is really working as a DBUS daemon, and other components runs on the custom DBUS session. Okay. And aside from this, IBUS daemon also manages engine installation and also input context actually used by the GTK module or something. So, okay. Yeah. So the issues of this architecture. Sorry. So IBUS has other issues except performance, because the implementation has some glitches still. Namely, IBUS has started in 2008, and at that time there was no asynchronous stuff. So the API is designed as synchronous. So some part has been rewritten as asynchronous, but still some other parts are synchronous only. So it causes some performance issues. Also, it is a long-standing issue, but when we install other engines from network, it is not immediately decognized. So we should fix this, but it is not that easy. Also, when an engine crashed, it doesn't recover it automatically. It is also very difficult to implement. So, but we should definitely fix it. And the worst thing is test case is about 30%. But maybe increasing recently. So I'll propose the new architecture here. The goals are simple, 3 goals. We want to support the new input method technologies like predictive input and handwriting. Also, don't sacrifice privacy or performance. So I'm thinking of this plan. First, the intelligent part is really engines, not the IBAS team or IBAS framework itself. So it would be probably good to make engines more like ordinary GNOME applications or services. And currently we use custom .xml file to register engines, but we could use simply .desktop file. And also, I'm not sure about the details of sandboxing. For addressing the privacy issues, we can benefit from the application sandboxing. Also, and the second approach is based on the fact that IBAS daemon is not so crash so frequently. It should be stable. So it can be library instead of the clone of the DBus daemon. Okay. So and to provide some services like user interface or engine activation, we can use session bus instead, because these protocols are not very frequently used. But we should also provide some high performance connections between the client and engines. So also provides a way to communicate between client and engines directly. So this is the first slide of the proposed architecture. So we drop the IBAS DMO, but use the session bus and these actually 3 libraries. Three libraries help communicate with these modules. And engines, probably client, if client wants some engines, then it asks the panel library to create engines, then activates this engine, and then tell the client the engine address, and then the client can directly communicate with engines. That would be simple. And also, the reason why we provide 3 libraries is because we can implement this architecture without breaking the compatibility with current IBUS usage in GNOME Shell or some GNOME Shell. By using G-object introspection. And also, the libraries can be strictly versioned, and we can provide some new UI elements as an extension. And okay. Finally, we can manage connections between client and engine. So, sorry. That's all. Any question?
So, how would that be useful to KDE people?
KDE.
The Windows it's totally unusable for KDE.
A difficult problem, but maybe we can provide the traditional IBUS daemon replacement using the IBUS panel library.
Also, how to ensure the security of input events and the candidate list. Because if you are on session bus and there is no encryption protocols encoded, everyone can register and listen to all the events.
Yeah, that is a good point. Can I'm not sure it can be possible to ensure any security on the candidate list because it is out of the user interface components. Sorry.
I think in a sandbox application world, the connection that an application would have to the session bus would be private to that application only. So I mean, I think from that point of view at least, you have a secure transport and no other application will have access to that socket.
But it isn't possible because there is an M panel that is used to display the results.
But the shell is like the shell itself would be a system process in that sense, wouldn't it? So it would be, that would also have its own privileged connection. If you mean like storing something in the application, then sure, that would need to be in process. So if you wanted like an in-application pop-up, but if it's shown by the shell, that would seem to be, I mean, but we need sandboxing in order to make that secure.
Do you think this architecture would work the same way under Wayland, or would you want to like move some of that into the compositor?
Yeah, that is the basic idea to make the IBUS demo into the library.
I more care about how the key press events or key codes are sent to IBUS and the reason. How that is handled.
Maybe does it not?
So first we then get a key press event, and how does it fit to IBUS?
Yeah. The Wayland if method protocol is still not fixed, so maybe we could use it, but I'm not sure the current status of the protocol. Perhaps we still continue using GTKI module and directly communicate via dbus or something.
Who would take care of the UI, as in the Windows panel with the alternatives? I mean, you currently have the root coordinates, you get the root coordinates from the IAM module, and you put the window
Right.
nearby, but on Wayland that's
Yeah.
not going to work as well.
Yeah.
And also there must be some string editing stuff in the text box. So, and there are something like Predate that's working as he is showing when you type something in the gedit, and you can edit the string as already committed, seems committed, but with standalone. And that needs some more client interaction with the weekend where the application is.
Something that we can replace
Yeah, I mean, didn't the Wayland Input Method Protocol have for this this pre-edit essentially? Isn't there the concept of a subsurface that's somehow shared between the client process and then whatever is providing that input method? I don't know what the status of that is. That was a long time ago that I looked at it.
And for the performance issue for DBus, in our observation at China, we have done a lot of experiments, and we are doing the work with CIDX, KDBus solve the problem totally, because it is lightning fast to implement this.
I think the performance issues mainly resides in the switching of the engines, maybe. That can be caused by many ways because of the synchronous API or some focus tracking thing.
And it is currently impossible to replace IBUS, I think IBUS UI GTK3 to do anything that you want. In China, it is a very common use case that people are going to use different UI implementation. And the UI is a standalone application. And we have much more features on the text, the candidate list itself, especially for example, skin support or anything. But it is not going to happen under current IBUS architecture or your proposed one. I wonder if you have a solution for that, or that is still pending.
Yeah. Maybe the candidate list is always a problem because some people also don't like the current GNOME shell candidate list because it is not look like a GTK widget or.
For IBUS, I need to write UI-related code for every engine, and also dealing with IBUS UI GTK3. So that is two-part work for every engine. That is sort of unacceptable for the developers because they need to maintain their UI-related code. But in your architecture, in the mockups, it is engines are dealing with the algorithms itself without doing any other stuff. But IBUS is abusing this design.
This is totally a different topic, but when you're discussing updating the language model and the difficulty of that, how often is it updated now? Is it once per release?
Yeah, normally we only provide the entire language model on each release.
Right. So it goes through the normal QA testing process ahead of that, and that's complexity if you were to update it more frequently.
Maybe to test the language model is very difficult. Actually, you need the correct answer set, and compute the precision and recall from the conversion result. So the first step is to correct the answer set to test each release. Currently we only use the fixed set, but that should be fixed.
I have one more question about language models actually. I wonder, it would also make a lot of sense to have predictive input in terms of touch, like the on-screen keyboard that we have.
Yeah.
Is that something that could be reused there, or in what form is this database accessible for us?
Yeah, it should be used. It should be able to use too. Yes, because it has usually three grams, three consecutive words, so we can provide some prediction test of the previous input words.
and in the proprietary operating system world, how often are language models or current features of the input methods?
They do that online, like class.
Oh, they
They
are
deliver
always
it.
online.
Yes, not always online. There is acceleration of the online part that deliver the second candidate from the cloud, and also dictionaries are patched like something live patching.
How
does
often
work
does this
offline?
happen?
I think yes, every week, because they are almost backed by search engine providers, and they have a very large user base and streaming space.
Are you saying they all require a live internet connection to work, or just that the
Not
updating
always.
is-
It can work offline, but when you are connected,
It does it.
Yes.